Hello students, this is a video for the topic tests on quant that we have at Bodhee Prep for you. The idea of these tests is once you cover the basic concepts of a topic, you can refer to these tests. There are multiple tests on each topic and check whether you are able to apply the concepts in a test manner or in a test scenario or not. Once you take a test, there is a video with every test which gives you the solutions and a brief analysis of what should have been a good attempt for that given kind of a test. There are more than 200 such tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. So make sure to download the app and use these tests as much as possible. This video specifically is on the topic progressions, and this is the second test on this topic. Overall, this was, I think, a medium moderate level of difficulty test with about 6 questions net correct, giving a 95 plus percentile. And the attempt time for me would be about 20 minutes to go through all the questions and finding and solving those 6 questions that we need. If we look at the questions, the first question is root of x square plus 3x plus c are alpha and beta, while the roots of x square plus 21x plus d are beta and gamma, if alpha, beta, gamma and arithmetic progression. So we can say alpha is alpha, beta is alpha plus d, gamma is alpha plus 2d. Now the sum of roots, that is alpha plus d, alpha plus beta, in this case will be minus 3. 2 alpha plus d is equal to minus 3. And in the second case, beta plus gamma, beta is alpha plus d, gamma is alpha plus 2d. Sum of roots in this case will be minus b by a, which is minus 21, which means 2 alpha plus 2d or 3d is equal to minus 21. This is equation 1, this is equation 2. We subtract 1 from 2. 2 alpha minus 2 alpha, 3d minus d is 2d is equal to minus 21 minus of minus 3, which is minus 18. D comes out to minus 9. And therefore, if we put the value of minus 9 say here, we can write 2 alpha is equal to minus 2 alpha minus 9 is equal to minus 3, which means 2 alpha is equal to minus 3 plus 9, which is 6. Alpha is equal to 3 divided by 2. And therefore, the roots become 3 minus 9, which is minus 6, and minus 6 minus 9, which is minus 15. We have to find the value of CD. C will be the product of the roots, which will be 3 into minus 6, which is minus 18. D will be the product of roots, which is minus 6 into minus 15, which is 90. And therefore, C upon D will be minus 18 upon 90, which is minus 1 by 5. Option C. I think a straightforward question. Using the sum and product of roots of the quadratic and the fact that AP has the common difference same, we can find the values of the roots. From there, the required value CD, not more than 2 minutes to solve the question. 1 upon 2 square minus 1 plus 1 upon 4 square minus 1 plus 1 upon 6 square minus 1 and so on till 1 upon 20 square minus 1. This is a square minus b square. Putting square on a 1 does not change the value. So every denominator is a square minus b square, which is nothing but a plus b into a minus b. So 2 minus 1 will be 1 into 3 plus 1 upon 4 minus 1, 4 plus 1. 3 into 5 plus 5 into 6, 6 plus 1 into 6, 5 into 7. These are odd numbers essentially, 1, 3, 5, 1, 3, 3, 5, 5, 7 and so on. Finally, the last term will be 1 upon 20 minus 1, 19 into 20. Now, the difference of the denominator is 2. So if I multiply and divide this entire thing by 2, we'll get 2 by 1, 2 upon 1 into 3, plus 2 upon 3 into 5, plus 2 upon 5 into 7, and so on till 2 upon 19 into 21. The first term can be written as nothing but 1 minus 1 by 3, 3 minus 1, 2 upon 3, plus 1 by 3 minus 1 by 5, 5 minus 3 upon 3 by 5, plus 1 by 5 minus 1 by 7 and so on till 1 by 19 minus 1 by 21. As we can see, minus 3 plus 3 minus 5 minus plus 5 minus 7 will cancel out till minus 19, and the terms that we'll have left with are 1 by 2 into 1 minus 1 by 21. This is nothing but 1 by 2 into 21 minus 1, 20 upon 21, and therefore 10 upon 21. Option B becomes my answer. Again, not a difficult question. You would have come across such questions while practicing the concepts. Basically, it boils down to breaking down this kind of a term in the denominator. Reaching this term could be a bit of a challenge, but after that, the process is pretty simple. So about 2 to 2.5 minutes to solve the question. How many terms of the sequence given below are integers? The sequence is 21, 7, 21 by 5. And so on 21, 2n minus 1, where n is natural number. The first term is 21 upon 2n minus 1. 2 minus 1, which is 1. The second term is 21 upon 2, 2s are 4 minus 1. 21 upon 3, which is 7. 21. So basically, 21 upon odd numbers is the sequence. Which of these will be integers? They will be integers as long as 21 is divisible by the number. So 21 is divisible by 7, and then 21 is divisible by 21. So here, and here. Basically, 21 is 3 into 7, and therefore has 4 factors: 1, 3, 7, and 21. For these 4 numbers in the denominator, we will have integers, otherwise we will not. Hence, option C becomes my answer. This is an easy question, should not take more than a minute and a half to solve. The 23rd term and 32nd term of an arithmetic progression, of a geometric progression, are the number of factors of 54 and 72 respectively. What is the geometric mean of the first 54 terms of the progression? 23 plus 32 is 55. 54 plus 1 is 55. Okay. Now, first of all, let us look at factors of 54. 54 is 27 into 2, which is 3 cube into 2. So, number of factors, or the 23rd term will be 3 plus 1 into 2 plus 1, which is 8. 1 plus 1 powers. If we look at 72, 72 is 9 into 8, which is 3 square into 2 cube. So the number of factors here, that is the 32nd term. 32nd term will be 2 plus 1, 3 into 3 plus 1, 4, which is 12. We have to find the geometric mean of the first 54 terms. This is 32. So now, if we look at it, geometric mean of the first 54 terms of a arithmetic geometric progression will simply be the geometric mean of the first and the last term. That is root of A1 into A54, which will be the same as root of A23 into A32. Because 1 plus 54 is 55. 23 plus 32 is 55. A23 is 22 terms ahead of A1. A32 is 22 terms behind A4, and therefore the product will be same. Or another way of looking at it could be A1 is nothing but, say, the first term is A. A54 is A into R raised to power 53. Therefore, A1 into A54 will be A square R53. If you look at A23 and A32, A23 will be A into R22, A32 will be A into R31. If we multiply, we'll get the same number, that is A square R raised to power 53, 22 plus 31. And therefore, the geometric mean of the entire thing will be nothing but root of the 23rd, the product of the 23rd and the 36th term, the 32nd term, which is root of 8 into 12, which is root of 96. 96 can be written as 16 into 6. 16 is root 16 is equal to 4 root 6. Option D becomes my answer. Again, I'd say a moderate level of difficulty question, but basically the calculation involved is just finding the number of roots. After that, we just have to realize that we have to take the root of the product, which should not take too much time. So about minute and a half to 2 minutes max to solve this question. The 30th term and the 80th term of an arithmetic progression are 12, 1 by 25, 36, 3 by 25 respectively. If the total number of terms of the progression is 175, what is the ratio of the sum of the first 75 terms, A1 plus A2 plus A3 up till A75, where A n is the nth term of the progression to the sum of the last 100 terms. A76, A77 up to A175. Again, this is nothing but sum of the first 75 terms upon sum of all the terms minus the first 75 terms. A1 up, A2 up till A175 minus A1, A2, A3 up till 75. If we remove the sum of the first 75 terms from the total, we'll get the sum of the last 100 terms. Now we look at 38 and 88. If we look at the first 75 terms, A1 to A75, the term in the middle will be 1 plus 75 by 2, which is 838. And therefore, we can say that the sum of this series is nothing but 75 by 2 into A1 plus A75 by A1 plus A75, n by 2 into first and last term. First and last term or by 2 is nothing but 38. And therefore, the sum of the first 75 terms will simply be 75 into the A38, which is 12, 1 by 25. Do we need to write this down? Calculate it. Okay. 12 into 25 will be 301. 301 upon 25. What will be the sum of the well, all the terms? If you look at A1 to A175, the central term will be 75 plus 1, which is 175 plus 1, 176 by 2, which is A88. And therefore, A88 is nothing but A1 plus 175 by 2. The sum of this series will be 175 by 2 into first plus last term, that is A1 plus A175. A1 plus A75 upon 2 is the A88 term. Therefore, the sum of the entire series will be 175 into 36 into 25. 903 by 25 minus 75 into 301 by 20. This becomes my net expression. Now from here what we can do is, I'm writing it again because I will cancel out some terms. Sorry. Instead of multiplying, first cancel out whatever terms that we can cancel out. So 25 is there in each of the term. 301, 301, this becomes 3. 301 into 3. If we divide by 25, 25 threes are, 25 threes are, 25 sevens are. So net we get 3 upon 7 threes are 21 minus 3, which is 3 upon 18 or 1 by 6. Therefore, the ratio becomes A, 1 is to 6. And that becomes my answer. I think level of difficulty wise moderate. What we could have also done was, since there are two terms given, we could have found out the value of A and D, use those values and put them into the formula for the sum of terms and then found the ratio. But I think this was a little easier to solve, and therefore going with this. 1 is to 6 becomes my answer. About 2.5 minutes to solve. An arithmetic progression is given by 2, 4, 6, 8, and so on. Starts with 2 gets added up to n terms if the sum of the last 5 terms and the first 5 terms in the progression is 130. So A1, A2, A3, A4, A5, A1, A2, A3, A4 and A5, these are the first 5 terms. The last 5 terms will be AN minus 1, AN minus 2, and so on, and AN minus 4. Now for an arithmetic progression, we know that the sum of the first and last term is same as the second and second last term, is same as the third and third last term, and so on. So if we add these terms, we'll have A1 plus AN plus A2 plus AN minus 1 plus A3 plus AN minus 2 plus A4 plus AN minus 3 plus A5 plus AN minus 4. The sum of the last 5 terms and the first 5 terms is 130. These two terms or every pair will have the same value, and therefore we can say 1, 2, 3, 4, 5. 5 into A1 plus AN is 130, which means A1 plus AN is 26 divided by 5. We know that the first term was 2, therefore 2 plus AN is equal to 26, which gives us AN as 24. Now, what is the general term of this series? The general term of the series an is nothing but 2 plus n minus 1 into 2. When the first term is 2, the second term is 2 minus 1, 1 into 2, 2 plus 2, 4, and so on. And therefore, if an is 24, we can say 24 is equal to 2 plus n minus 1 into 2, which gives me 22 upon 2. N minus 1 as 22 by 2, which is 11, and therefore n comes out to 12. So find the sum of all the terms of the progression. There are 12 terms, therefore the sum of the progression will be number of terms upon 2 into first term plus last term. 12. Sorry, and last term is 24, not 24. This will be 12 into 26 by 2, which is 13. 156 becomes the answer. Again, I think easy question, should be done in about a minute, minute and a half. The numbers are easy to match, therefore I'm saying easy question. Consider the sequence A1, A2, A3 such that A1 is 81.33, A2 is minus 19, and AJ is AJ minus 1 minus AJ minus 2. That is, every term is a difference of the two previous terms for J greater than equal to 2. What is the sum of the first 6002 terms? Now, A1 is 81.33, not difficult to calculate. A2 is equal to minus 19. Put J as 3. A3 will be nothing but A2 minus A1, which will be minus 100.33, 9100. A4 will be A3 minus A2, minus 100.33 plus 19, which is minus 81.33. A5 will be A4 minus A3, minus 81.33 plus 100.33, which is 19. A6 will be A5 minus A4, 19 minus plus 81.33, which is again 100.33. A7 will be A6 minus A1, A6 minus A5, which will be 100.33 minus 19, which comes to 81.33, which is same as A1. A8 will be A7 minus A6, which is 81.33 minus 100.33, which is nothing but minus 19, which is the same as A2. And therefore, the pattern will repeat. So every 6 terms of this pattern will be 81.33 minus 19 minus 100.33. Then we'll have minus 81.33, 19, and 100.33. As we can, this pattern will repeat for every 6 numbers. As we can see, the sum of this will be 0 because each term has its negative term in the sequence. The sum of these terms will be 0. So A1, A2, A3 up to A6, the sum will be 0. A7, A8 up to A12, the sum will be 0, and so on. This will be true for every multiple of 6, and therefore A 5995 plus A5996 plus A5997, A5996, 998 plus A5999 plus A6000. Again, a multiple of 6. Till this point, all the sums will be 0. So we are basically looking at A6001 plus A6002. These terms will be equal to the first and the second term because the terms repeat after 6 terms, and therefore A6001 will be 81.33. 6002 will be minus 19. 81.33 plus minus 19 will give us nothing but 62.33, which is option B. The question is moderate level of difficulty. The attempt time might go up to 150 seconds. But the point is, it's a question that you would have come across while practicing, and therefore kind of becomes a little doable. How many terms in the expansion of 3 raised to power 1 by 5 plus 13 raised to power 1 by 8 raised to power 1000 are integers? Now, if we open this binomial, the nth term of this will be 1000 CR, or the R plus 1th term, sir. r plus 1th term will be 1000 CR into 3 raised to power 1 by 5 into r into 13 raised to power 1 by 8 into 1000 minus r. Which means the term becomes 1000 CR. Again, this will always be an integral value. 3 raised to power r by 5 into 13 raised to power 1000 minus r by 8. Now, clearly for this to be an integer, r by 5 and 13 minus r by 8 have to be integral values. And therefore, r has to be divisible by 5 and 1000 minus r has to be divisible by 8. Since 1000 is divisible by 8, r also has to be divisible by 8. So basically, r will take values which are divisible by 5 and 8. The LCM of 5 and 8 is 40. Hence, as long as r is a multiple of 40, we will get an integral value. Now, since r can take values from 0 to 1000, multiples of 14, this is basically 40 into 1 will be the first value, 40 into 2 will be the second value, 40 into 25, which is 1000, becomes the last value. Also, r can be 0. If r is 0, we will get this becomes 1. 13 into 13 raised to 1 by 8 into 1000 becomes 1000 by 1. 8 is 125. So it will start from 40 into 0, it will go up to 40 into 25. Hence, 26 values of r are possible, which will give us the expression to be integral. That becomes my answer. I am calling it a difficult question. It is a little, I find it difficult to figure out in the first step how to go about the question and fix values of r. Once you're able to see the binomial expansion, the common term, then the calculation should not be very difficult. So I'm saying 2 to 2.5 minutes to solve. But in terms of level of difficulty concept-wise, I'm saying difficult question. The geometric mean of the length and breadth of a rectangle is 4. If the length is L, breadth is B, geometric mean root of L into B is 4, which means L into B is 16. And the arithmetic mean L plus B by 2 is 5, which means this is 16. L plus B is equal to 5 into 2, which is 10. What is the ratio of the numerical value of the perimeter of the rectangle to that of its area? Now, if we solve for L and B, it's pretty clear. L and B have to be values 8 and 2. These will be two numbers which will give us product as 16, sum as 10. If we want to solve, we can go ahead and solve as well. From here, we can write L is equal to 10 minus B, substitute it here. 10 minus B into B is equal to 16. 10B minus B square is equal to 16. B square minus 10B plus 16 is equal to 0. Again, we'll have to find two numbers which add up to 10 and have a product of 16, which we already did. B minus 8 into B minus 2. So B could be 8, in which case L will be 2. B could be 2, in which case L will be 8. We have to find the ratio of numerical value perimeter. Perimeter is twice perimeter of the rectangle. Twice of L plus B. Area is L into B. We did not even have to solve for L and 8. We already had the values of L plus B and L into B. L plus B is 10. So L into B will be 20. 2 into L plus B will be 20. L B is 16. Hence the ratio comes out to 5 by 4. Again, all of this calculation was not needed. We simply have LB as 16, L plus B as 10, put the values and get the answer is all we needed to do. Easy question, not more than a minute and a half to solve. All we need to know is the formula for arithmetic and geometric means. If x, y, z are three positive numbers in geometric progression, x raised to power 15 is equal to y raised to power 20, z raised to power and find the value of n. What we can do is, looking at the LCM of 15 and 25, which is 75, I'm saying let this be equal to k raised to power 75. Now, if x raised to power 15 is k 75, taking the 15th root, x will come out to 75 by 15, which will be k raised to power 5. Y raised to power 25 is equal to k raised to power 75. Taking the 25th root or dividing the power by 25, y will come out to k cube. X therefore, if you look at the common ratio x by y is k5 by k cube, therefore k square. Which means if we look at x, y, z, x is k5, k raised to power 5, y is k cube, gets multiplied by k square, or here it is being divided by k square. The ratio will be same. Therefore, the value of z will be k for them to be in geometric progression. K5 divided by k square becomes k cube, divided by k square becomes k. Now, k raised to power n, z raised to power n is equal to k raised to power 75 from here. And therefore, k raised to power n is equal to k raised to power 75, which means n has to have a value of 75. Option D becomes my answer. I think easy to moderate question. Solving time should not be very high. Cracking 75 is the challenge. Once we do that, the question is straightforward. Now, in terms of the overall test here, moderate test, 6 net questions required for a 95 percentile, 20 odd minutes to find them. For me, the questions that I would choose, my 6 would be 1, 3, 4, 6, 7, 9. Which are these? Definitely doing this, both the concepts of the quadratic and series. Both are simple ones. So attempting this. This again, unless you know the series, it might be a little difficult to solve. So not counting this question. This was a very doable question. Just 4 factors of 21 were to be found out. This also, I think, was a manageable question because even if you're not able to spot that 23 plus 32 is 55, which is the first and the last term, even then, finding the value should not be difficult for A and R from where we can get the geometric mean. So attempting this question as well. This question could be a little difficult to crack, especially if you start finding A and D. The calculation can get too long, so not counting this question as the easier 6. This was, I think, a pretty easy question, should have been attempted. This also because similar questions we've attempted earlier, and the pattern is very common. It repeats after 6 steps. Therefore, counting this an attempt question. This, I think, was a difficult question in terms of concept. This was a pretty simple question. You get the value from the equation, put the value, and get the answer. Again, I'm not counting this as an attempt question. If the powers were not as easy, it would have become a little difficult to solve for me. And therefore, for me, if I have to look at my 7 easy questions, 6 easy questions, they would be 1, 3, 4, 6, 7, 9.